Dear Markku, thank you very much for your nice organization. I attended ACCC Impact Week. It was very good and it's beautiful for me. By the way, I met with you, so I want to share your experience with my environment. So I want to ask some questions.
You are very welcome.
First of all, what would you be great most important advice to tomorrow's scientist?
It's very important in future scientists that they learn this kind of multiple ways and have multiple tools to meet scientific questions, scientific challenges, including of course all these kind of environmental grand challenges like climate, air quality, water, energy and food supply, biodiversity, and understand that they are interlinked, and understand that we need to solve them together, not one by one, together, all those grand challenges, and that's why it's important to learn different tools.
Yes.
And although having this kind of big picture, it's good that young scientists would also learn to make very deep studies, deep understanding of some specific topic.
Yes. By the way, how did you become interested in science?
I think that I have been always interested in this kind of open questions, and in science point of view, when I was a schoolboy, I was pretty good in mathematics, and then a little bit older one, physics and chemistry and these things. And when I started my studies in university, I started to work to study theoretical physics and physics, and later on a little bit meteorology and chemistry, and mathematics of course. And then I was, let's say, quite normal student. Not very good student, not very bad student, but then when I start to make my master thesis, it turned out that the new science is something which I like a lot, which I'm pretty good, and that's why I decided to let's try to be a scientist.
So your master studies motivated you in science, maybe?
Yeah, in master studies it was part of physics already in that time, and my topic was analysis of risk of new and renewable energy production, different energy sources and energy production. I find out the risk analysis of this energy production. And one of those topics inside my master thesis is atmospheric pollution and health effects of that. And then I was thinking in that time that it's easy stuff, but it's not. And then I go to more and more detailed in this kind of atmospheric science, aerosol physics, aerosol chemistry, atmospheric chemistry related things.
So
it has been step by step actually. Although I have now thinking back 50 years, I can see that how I have developed, but still the development itself, I have never think that yes, I will be scientist before I really was scientist. And before masters, I didn't think that I will make my PhD. And then, but after master, it was very clear to me that yes, I will make the PhD. And then before PhD, I had no idea that I will stay in university or academy. And but after PhD, it was very clear that yes, I will stay here.
what is your biggest dream in science?
Biggest dream is certainly that we get more this kind of very comprehensive observatories, where we are able to get really long-term comprehensive data from different countries, different ecosystems, different environments, and then that people can use it openly. And then we can get discoveries out of that which can then help us understanding all these environmental grand challenges.
And by the way, what would be your most important advice to tomorrow's scientists?
This is something which is a little bit okay. Actually, what I say typically in my lectures, which I actually show also this figure, this kind of very foggy, cloudy bridge. Go to unknown. Try to go to unknown. If you are able to go unknown mentally, then you are able to make very big discoveries. But you need to be ready to go unknown, and when you go unknown, you are not really in your comfortable zone. You are not happy maybe all the time. You might feel stupid even, and that's the point that young scientists one simply need to go unknown.
How do you create productivity in your work?
This is also a good question about the productivity. This is a little bit difficult to say how to do it in practice, but I try to actively do those things what I'm doing, and proactively, and this kind of productivity comes of course with lot of work and ideas, but also thinking that thinking is important, crucial to think enough. And people can easily say that everybody is thinking, but really to think scientifically it's an effort, and it's a little bit different than only follow what others are doing.
Teamwork, how about your idea about teamwork?
The teamwork is, at least for me, very, very important. I cannot organize this kind of events like this ACCC Impact Week without teamwork. Teamwork is the key of the all activities.
For example, for future scientists, they can begin team working during the undergraduate?
Yes, sure. It's important. And for example, we have this kind of winter and summer schools where we also automatically teach people to do teamwork.
Yes. What other things you want to say?
Let's say that it's important to be curious. It's important to like what you are doing. And it's also good to learn different things, different items, different tools. And the important part is to learn to think, learn to write, and learn how to get into unknown, and also to how to find out new tools for how you can solve your problems.
How about collaboration, usually international collaborations?
It's a really one of the key issues. Also, this international, both let's say national, local, national, international collaboration is important.
So workshop, seminars,
yes,
symposiums, conference, etc.
Exactly, and then kind of research visits, joint campaigns, at least in my area where we are making a lot of observations. We have joint campaigns with other countries, other institutes from other countries, and etc. in practice all around the world.
Thank you very much for
timing
your time with us. I hope we can do good collaboration in future studies.
Yes, I hope so too. And thank you for being with us this week.